a graph illustrating the problem. The parabola is the red graph here, y equals x squared. This blue line is x equals 4. The green line is the line y equals 1. And this light red region is the area that we want to revolve about the y-axis, which is this purple dotted line here. Now you can use two methods. You can use the shell method, which is probably the most straightforward, which is illustrated by this definite integral right here. If you're going to use the shell method, you want to think of a typical shell parallel to the axis of revolution. That's the height of your shell. And an expression for the height of that shell is, again, for any x between 1 and 4, we're going from 1 to 4, this height is x squared, take away 1. So that's what this is right here, the height of the shell. The value x is the distance from the axis of revolution to the center of a typical shell, or the average radius. And that would be x minus 0, or just x. And of course, for the shell method, it's 2 pi times that. And we're integrating from 1 to 4. You can see we get 353.429. If you want to use the washer method, then you think of the typical shell as perpendicular to the axis of revolution. So that would look like this. And now we have pi times the outer radius squared minus the inner radius squared. So, and we're integrating along the y-axis because our typical rectangles are perpendicular to the axis of revolution, moving along the y-axis. This time we're going from y equals 1 up to 16. The outer radius is the distance from the axis of revolution to the outermost point, and that's always going to be 4. The outer radius is always going to be 4, so we've got 4 squared here. That's the outer radius squared minus the inner radius squared. Well, the inner radius is this distance right here. And that's an x distance. So that means we have to solve the equation y equals x squared for x in terms of y. For each y, that distance is the square root of y. But the square root of y squared, of course, is just going to end up being y. I'll let you take care of evaluating these definite integrals. Here's proof that the correct answer is 225 pi divided by 2, and you get the same answer with either method. There you go. Hope that helped.